Today's is the Python practice on clustering. In this Jupyter notebook, we'll explain about how we deal with K means how we deal with the hierarchicals, how we select K means the number of clusters, how we select how many number of clusters we need to dissect. In hierarchical, we will use dendrogram. How to cut dendrogram? I will see those steps. As usually, you people know pandas. This library, pandas library will help to do with data frames in Python library. Data frames is nothing but the whatever the data we are collecting from the to build a model. NumPy is the actually whatever the operations or whatever the equations we are solving, computer will works on the only numerical data. So that's why this NumPy will useful to do the mathematical operations like mean, max, anything. This is the library matplotlib. This library will be useful visualization purpose. For example, sometimes instead of seeing the numbers, it's better to show some information as a visualization graph. So it gives the more information rather than numbers. That means the people it is easy to understand information as much as fastly. If we want to compare, if we want to understand the pattern through the numbers, it maybe take some time. But if we are represent that numbers as a graph, it will easy to understand. It will saves us time also. The C1, SNS, and the Matplotlib, these two are the visualization library in Python. Plotly also. These are the three different libraries. These will useful to plot the whatever we want. For example, these Plotly and C1 Matplot is the first library in Python. Then after they extend to the Plotly and Cbon. Based on the, for example, let's say Matplotlib, we are able to do 2 or 3 graphs at a time. But coming to the Plotly Cbar, for example, did you people observe there is one x-axis but multiple y-axis? If we want to show something, for example, based on the year base, actually in the x-axis we'll take the years, last 10 years. In y-axis, we want to see what is the date, how data is changing. What is, for example, what is the revenue of the particular company? Let's take the Amazon, Google, Sony like that. So for the x-axis, there is the same information, last 10 years information. But the y-axis, Amazon revenue is different from the Google, Sony. If we want to see that type of plots, these plotly will be useful. Like that, whatever the based on our requirement, which type of graph we want to draw, based on that we need to select library. That's
Okay.
that's okay. Actually, mostly for this small graphs only, we will use this one. If we want to do really data analyst job, we won't go for these libraries. We won't go for the writing code for the to create a graph. Mostly, most of the people will select Kibana, Tableau, Grafana. There are a
Mhm.
lot of yes, a lot of visualization tools are available. So we'll go for that one. See here, I have taken this one all seasons CSV file. Did you see? Did you observe previously? We'll do one thing again. This is the kernel restarting. Restarting means if we restart our Python library like this, whatever the some cells, whatever the some functions executed previously, it will become reset. For example, let's say whenever it guess the PD is not defined. Name error PD is not defined means that, for example, if it is related to the libraries, we did not executed libraries. That one. If it's maybe, for example, let's take the all seasons. Let's take the one variable. For example, if I executed here, DF is
Mm.
not defined means it's not related to the library. So first, whenever we observe name error, we need to check whether it is related to the library or whether it is related to the any variable. Here we call data frame is the variable. So if it is the library, we need to install library.
Mhm.
Yeah. why I'm saying about the name error, let's see, this is the name error. But if we are not able to identify this is the Python installation problem, it is the variable assign problem, what we'll do, we'll go for the, we'll go and check this directly here, but we won't get any results, whatever we are expecting. So that's why
Yes.
there are some errors we need to understand based on. While working, you will get, but I'm saying whenever I got the chance to say something, we'll inform. This is the data. We have like this data, that is the player name, team abbreviation, is player height. So this is regarding something, some game. Oh, which college this team is belongs to, which college, country, draft year, town, season. So whatever the here data, whatever the columns you can observe here. You people, I already told you, if we want to see how many numerical data and how many categorical data, how many string data is available in that data. That means, for example, here we have that 20 features. If we want to check which type of data is existed in the data, this info pandas will support to info describe this type of functions, head tile. If we want to see top records, this head function will be useful. If we want to see which type of data is presented in that one, this one useful. Let's take here, whatever the float means, this is the numerical data. Whatever the object means, this is the string data. String means nothing but alphanumeric letters. Numerical data means
Mhm.
that's completely mathematical digits. If you want to observe something, for example, data variation, from where to where this data varied from. If you want to know that, this describe function will be useful. For example, let's say age, we have the age column, but we don't know players are within the 20 to 25 years, whether within the 20 to 30 years, you don't know. If you execute this function, what will it will show? So mean means the least age of the player is 38. Max means 44. The max age of the player is 44. So the player's age is lies between the 18 to 44.
Mhm.
Yeah.
Yes.
See, let's say 50% is the 27. That means 50% of the player's age is less than 27. Remaining 50% player's age is the greater than 27. This is just how is the data, what is the, for example, let's say that's what I said. For example, we have the data points till 1 lakh, 2 lakhs, but how in one feature, data points like that. But for the some records have for the same feature, we have the values 10, 100, thousands. But on an average, overall the values are within lakhs. But some values, for example, we have the 1 lakh records. Out of the 1 lakh records, there might be 100 or 50 records are very less numbers with less than 1,000. We don't know
Mm.
by seeing the data directly through by using head, tail, anything. This describe function will be useful to see that one. For example, let's say this one, this GP, this data values are vary from 1 to 85.
Okay.
Some yes, yes, like this. We are able to understand what this means count. This count means
Yeah.
number of the records. That's not a matter. This is same for
Yeah.
everything. Let's take the standard deviation. Standard deviation means how it varies. 4 means let's take we have the normal distribution. Yeah, we have the normal distribution. I told you
Yes.
uh, one standard deviation means 68% of data within the one standard deviation. If we have taken two standard deviation, 95% of the data lies between the two standard deviation. If we had taken three standard deviation, 100% data between the three standard deviation. Whatever the data points outside the three standard deviation, we call those are the outliers maybe. Or we can say this data is not distributed normally like that.
Mhm.
So the standard deviation will be useful. For example, let's take this is the standard deviation 4. What is that? If we want to check whether the 90% of data is under the normal distribution or not, you can do 4.3 means and an average 2 standard deviation means 9. It will become 9. Let's subtract and add 9 for the 27. Why? Because this is the mean value. Some data will lies on left side, some data will lies on the right side. So we need to check plus or minus standard deviation every time. So
Yes.
27 minus 9 means 18. So with this is with in left side, this is the within 2 standard deviation. 27 plus 44, sorry, 27 plus 9. It's not 44. 27 plus 9,
27 means
36.
36. Yes.
Yes, 36. So that it is the more than 2 standard deviation. It's 36,
Oh,
but here we have the 44. But we don't know how many people are have more than 36. For that purpose, we need to check out whether it is 1 or 2. It's not a matter. Why? Because this one is within 3 standard deviation maybe. Yeah, let's take the 3 standard deviation, that is the 30. 27 minus 30, 40. So near to that one. 4 standard deviation mostly.
yes.
Like this, we can able to check if is there any inappropriate. For example, if we observe any data, it's not a normally distributed, then we will check like this. See, categorical data, how we say, let's say country. For example, this tournament is conducted on the worldwide. Based on the country, we won't get the actually whenever we want to, for example, let's take cricket. If we want check a player, we consider his how he is playing previously, what is the his scores, what is how many centuries he did, how many runs he did. We will see that type of information
Mm-hmm.
mostly whenever why? Because it is the we want to select player.
Yeah.
So yes, players, what is the in which college he studied, in which country from he is, and what is the draft year. These are not that much information. Actually, not that much information. These information not useful to the to know about the his skills. For example, we have the one position, one data scientist position. What we will do? We will give ad. We in our company we have the one position for the data scientist. So some people, 10 or 15 people will apply for the this job. While interviewing, just in introduction, people will ask, "Where are you from? What is? Tell me yourself." Just we want to know about the how confidently he is saying his answers. That's it. But based on you, whatever the college you studied, based on whatever the place you studied, based on the whatever how many years you completed, based on that one, no one give a chance, a job chance based uh, technical skills, functional skills. Based on skills, they will offer job to you. So we need to select data based on our requirement. So here these team abbreviation, let's say here there are some columns. College, based on the college, we can't select players. Based on the country, based on the draft year, round, draft number. So these are the some categorical data which doesn't have any information about the player, which
Okay.
is this data is not useful to select a player for our for to play in the games. So that's why we are dropping some unwanted features. This is the drop function. Pandas supports a lot of functions for those data frames. Head, tail, info, describe, is null, fill NA. Like that, this is the one of the function, that is the drop, to drop the unwanted features. Now you can check how many features does we have. These, okay,
14. Okay.
like this. Yeah. Actually, here I am again. I'm introducing principal component analysis. Why? Because if we repeated same concept again and again, you people will understand. If I actually previously I told you only principal component, but this time I want to say how to use this principal component for the k-means logistic regression. Actually, this is not a separate model, PCA. It is the
Mm-hmm.
pre-processing technique. So before going to build a model, this is one of the pre-processing technique. Feature selection, this PCA, standardization, normalization, this unwanted features deletion. Everything is the pre-processing techniques before going to the to build model. Data preparation techniques. That's why here I want to introduce again you people how to use some pre-processing techniques before going to build a model.
Okay.
See, a player name. Actually, here we are clustering. This is the clustering problem based on the player name. So every player have the his own name. If, for example, let's take 4 5 people. Or for example, if we have there are 100 players, there might be chance to repeated some names. For example, uh, some name most of the people will you people know some people who are, for example, the people related to the god names like that. There is a chance some names repeated again and again, but there might be some parents things differently. Yeah, why we need to use same name for the every time we need to use my child want to be a different name, that's why they will give. So based on the name, we can't group them. For example, this is the categorical data. Means it is the identification. That's it. It doesn't have any information about the. This is just identification. That's why I am removing this one also. Okay. Did you people agree? I am removing this player name. Why? Because this is the identification purpose. In our name also, just identification purpose. We won't use our name for any other purpose.
Yes, ma'am, but
Yeah.
we dropped previously some of the variables, right? In previously also
Yes.
in upside. So why don't we drop in here only that the same player's name variable here only?
Okay. You can drop.
We can do right?
Yes. Yes.
Not in. Okay.
If you want, you can give this name here only.
Hmm.
Like how many, if you want, you can delete that many features. So here we need to give again 2. Why? Because here we remove
Hmm.
df3. That's
Yeah.
why.
We have to change the variable name wherever df3 will be there.
Instead of that, it's better to assign df3 or df2 to copy. If you want to, for example, let's say, uh, while doing these principal components, everything, for example, here we have the 1100 records, 11,000 records,
Mm-hmm.
11,145 records. So it is easy to read, it is easy to do everything. But in real time, we won't get this much of less data. We will get the data in lakhs, crores. So, if you want to execute to read that data, it will take at least 2 to 3 minutes. After you did something, for example, after reading, you did some, you have dropped some columns. But after doing some research, you want to reassign some features again. For example, whatever the you thought these are the unwanted features, after some time you realize that out of these features, these 2 features are useful to build a model. At that time, you need to read data again. Why? Because you
Okay.
already dropped the columns, but you need to data. So it will take some time. Again, to read data, it will take 3 4 minutes. So to avoid that type of time wasting process, what once you read the data, whatever operations before going to the analysis, anything you can copy data into the some other data frame. So if
Mm.
you can perform any operations on this data frame, for example here df3. If you want to change, if you want anything again, you can go for the here. Why? Because you already uh, have the data in df2. What if you perform any operations on the df3, it won't affect on the df2. So it
Mm.
will, yeah, it will save some time, repeated data reading time.
Okay.
Actually, this is the excel sheet. That's why I'm able to, in our local computer, this is the excel file I have in my local computer, so I have read it very fastly. Sometimes we need to connect some other databases. For example, in real time there might be some production servers. Whenever we want to data, we need to hit the data. But the
Yeah.
hit, if we are hitting the database every time, it will affect on the product performance. That's
Hmm.
why there might be a lot of restrictions to hit the database. The people actually, the DB team, database team, whoever working on the database team, their own the people, they only have the access to hit the production server databases. Other people won't actually they won't provide credentials for the other people. If we want any data, we need to request them. Why?
Okay.
Because if for example, without any knowledge, if we are hitting like this, it will impact on the production performance. That's why we need to copy data from like this. It's better.
Okay.
So here, I already told you before going to the PC performance component details, we need to do standardization. Here I have taken this standard scalar. I send the F3 values to the X. Then after PCA. Here I am taking two components. This is the component one. I am assigning column names. This is the actually Panda series. Panda series. I want to convert Panda series into the data frame. That's why I'm assigning column names, component one, component two. Just I'm taking two variables. So for example, before going to that one, how is the data? Whether is there any differentiation? Let's see. Let's see this graph. What we feel. Whatever the data points lies between this one, these all are the same cluster, right?
Yes, ma'am.
By seeing this data point, what we will observe, the data points which are lies between this one are the same cluster. I'm
Hmm.
saying that one. Will you people agree?
Yes, yes.
Is there any chance there are different clusters lies between within this group?
Yes, ma'am.
Yeah. How do you identify that one? If, for example, in this
Ma'am,
particular
if
area,
we visualize in such a way that, like, when we do more, when we take, if we take, suppose, in x-axis, y-axis, if we decrease the width of the thing, so that we can visualize, ma'am, so that there might be
yes,
some distance or else difference.
yes. Here we are showing this graph in two dimensional.
Mm-hmm.
That is the x dimension and y dimension. So if we execute same operation, same thing in three dimensions. You know, people, 2D effect, 3D effect.
Yes, ma'am.
Like this, if we are able to include in that dimension, what will happen? The data points which are lies between here, some are in upper side, some are in lower side, some are in middle side. Some groups are inside, like that. So if we are able to execute this one on 3D dimensional, there might
Mm-hmm.
be lot of clusters. There might be chance to be like a lot of clusters.
Okay.
Yeah. So like that, by saying by if we are able to execute the same operation on the three dimensional, then we are able to identify the number of clusters. For that purpose, let's take here I have taken 80 clusters at the starting point. Let's see how is the data. Here K means I I assigned 80 clusters to the number of clusters. That is my K value is the 80. Let's see how is the graph now. Let's see. Here you can see this is the one cluster and this is the one cluster, right? Here light blue, sky blue color and light green color is there.
Mm-hmm.
Under these two colors, there might be one brown color.
Yes.
Yes. That means in 3D effect, there is lot of clusters. Here, this green color and blue color overlapping the brown color. That means if we are able to see this graph in 3D, we can able to see exactly there is might be some difference, some distance between the one cluster to another cluster.
Okay.
Like this. Let's say we have the elbow method to identify the number of different patterns existed in the data.
Ma'am, but one thing, okay, we have added the third dimensional also. Okay, previously there was two dimensional, so we were not able to make out. Okay, means how many clusters will be there. We have added the third dimension to mitigate that. and adding the third dimensional, we are able to see different clusters now.
Yes.
Adding the third dimension, how it is differentiating means one cluster to another cluster. It is based on the distance between the centroids, or means what? How it is distinguishing between one cluster to another cluster after giving it the third dimension.
Through the centroid only.
Okay.
K means first it will take randomly one centroid, then after again it will reassign the cluster based on the data points. See, so whenever we see two-dimensional, these all points are lies here only. Yes. If
Yes.
here we included the third dimensional, this one, what will
Mhm.
happen? The data points actually, if these data points all are lies in this two-dimensional, that graph will be looks like this one.
Yeah, the blue color one.
Yes, this one. But whenever we go for the third dimensional, let's
Mhm.
see the data points which are lies here. These are the one group. The data points which actually in three dimension also you can see this green color overlapping on the red color.
The red one, yes.
Yes, sir. These all colors overlapping on the blue color. If we are able to increase our dimensions 3 to 4, 4 to 5. So then we are able to differentiate our clusters very easily. Let's see here. Here they included other cluster also. See, in this dimension, this is the blue color, this is the red color, here is the green color. So if based on the how many dimensions we are increasing, we are able to identify the clusters that, for example, with a high accurately.
Mhm.
High accurately. Why? Because it is visibly it is very clear compared to two-dimensional. Three-dimensional is the good results. If we are increasing dimensions like this, the difference between the one cluster to another cluster, it is easy to identify.
Yes, ma'am.
But
But
but but but actually every time like this to by increasing dimensions we can't say which data points comes under the which data. That's why we will go for the k-means clustering.
okay.
For example, let's take this graph. Let's see this graph. These are the sum. But how do you know what are these points? What are these points? What are these points?
Yes.
No, for that purpose only. For to do that computation, we need to perform the these clusterings.
Okay.
Yes. So I have taken 1 to 11. Let's check what is the k value. See, based on this, uh, maybe 6 is better. I think. A lot of decrease on the distance.
Mhm.
If you people do you want to say any other one? 7, 5.
No, ma'am. I can see only six up to six.
Okay, I am this time I am assigning 6 is the 6 number of clusters. So plot will become like this.
Okay.
Don't worry. This is K means. Coming to the hierarchical.
Ma'am,
So
if here in this diagram we have assigned six, and then it has given us a plot dividing into the six clusters, right?
yes,
So one thing, so, can you please go in that diagram, ma'am, that dividing division into the clusters one? Yes. So
yeah,
this yellow spots is the
centroids.
centroid only.
Yes, these yellow points are the centroids. So based on the centroid, we will calculate the what is the distance between the centroid to the data points.
Okay.
Yeah. Actually, here we don't have any labels. How do we check k-means performance with labels? We'll explain. We have the another Python Jupyter notebook. We'll explain there. Just first, how do we are clustering? How do we are using our techniques to cluster, elbow,
Mm-hmm.
these things. So then after comes to the hierarchical clustering. Hierarchical clustering, actually, here we have the one technique to identify the number of clusters, that is the elbow. But in hierarchical, we don't have that type of feature. So it will produce dendrogram, definitely. So let's take from SciPy library, I installed the SEH. This is the, here I already told you there are a lot of algorithms for the to calculate the distance. Here I have selected Euclidean distance. If you people want any other, you people want to use any other algorithms, you can use. I will explain through the one technique. If you people interested to play with this clustering machine learning model, you people, you can use different algorithms. You can check how the model is building, how the clusters are changing, how the data points changing one cluster to another cluster, like that.
Okay.
See, hierarchical clustering is the time taking process. Why? Because first it will take each data point is a cluster, then after it will group in each and every level. So most of the people won't prefer for this hierarchical clustering. See, after preparing this one, we will execute again. I gave the 80 clusters at initial stage. So let's see the Harvest data. Previously, we already have checked in 6. That's why I gave here 4. This is the data like this. Okay, it takes some time. Shall we go for this one? There is no much difference. Let's say it will, previously I already showed you dendrogram. How is dendrogram? It is in a tree structure. After executing this one, we will get the dendrogram. So based on that dendrogram, we will select how many different clusters are presented in this one. So we'll give that many clusters for the agglomerative clustering, just like k-means, how we assign clusters 6 here, like that only. Okay. Coming to the
Yes.
k-means clustering, how we check. See, why I provided this means, just if you have any doubts in future, this Jupyter notebook will be useful to clarify those doubts, to understand more than that one. See, if in 2 dimension, if we are able to see like this, k-means will cluster like this one. For example, these data points, the distance between these data points are very less compared to this one. So based on this distance, it will cluster. Here are the same libraries what I installed previously. These warnings is nothing but, for example, let's take the pandas. We have the pandas latest version 3.10, like that. But still we are using pandas previous version 2.7, 3.1, 3.2. That time we will get some warnings. You can use upgraded library instead of this one. It will have the lot of features like that, some warnings, some instructions. That's why I'm ignoring those instructions. Here I have taken live CSV. Let's check how many records are available in this data frame. There are 7,000 records and 16 features. Let's see how is the data. Status size, status type. Instead of this one, it's better to go for the info. So then we can identify. There are 10 integer features, 3 string features, some null values also. Let's see. Observe this information. See, here 750 null values. See, here total number of records are 7,050. Here non-null cells are how many? 7,050. There is no null value. Let's say come to the column 1, 2, 3, 4. Here 0 non-null values. That means all are null values. All 7,050 records have the null values. Through this one also you can able to see how many null values are presented in the particular feature. People, are
Okay.
you understand? Non-null value means these, whatever these 11 features, these features doesn't have any null values. Why? Because whenever we execute the shape function, there are the 7050 records 16 features. So out of the 7050, all 7050 are non-null values. But coming to these 4 features, these are all null values. So if we observe, for example, out of 7050, we have the 6100 or 200 non-null values. Remaining all are null values. That means that feature have the 90% or 85% of values are null values. Based on that information, we will drop the columns. For example, see here. If we give the null values like this, if we execute only is null, it will say yes, false, and true. For these 3 columns are true, these 4 columns, remaining columns are false. If we add some function for this one, it will give the how many null values are presented in each feature. So here there are no null values in these 11 features, but here all are null values in these 4 features. So these are the unnecessary data. That's why I am dropping these 4 columns.
Okay.
Why I am repeating same every time? A head function, info function, describe function, is null function, draw function means before going to build a model, we need to perform all these techniques. It is mandatory. You people need to understand that point. Whenever we want to build a model, first we need to check what is the data. We need to check what are the different columns presented, whether it is a string or a numerical or categorical data. Is there any null values? Is there any unwanted features? We need to drop if is there any null values or unwanted features. If the data is very less than, but null values are also very less than, that means we need to fill that one. So these are the mandatory things we need to do before going to build a model. That's why I am introducing same concept each and every model.
Okay.
Yes, describe. If we want to check how data varied from 1 to, see, standard deviation is the 462. So it is very high. Why? Because here data is 0 to 4000. Standard deviation 462 means it is very high. For example, let's take data lies between 10,000 to 1 lakh. If the at that time, if the standard deviation is 462, that means that's very less one. But here the data lies between 0 to 4700. So within this one, the nearly it is the 500 standard deviation. So there is a lot of variation presented in this data, in this feature, number of reactions. So to understanding the how data varies in this particular feature, this will be useful. So we'll apply this describe function for the numerical data only. Why? Because we are calculating mean 25%, max, everything on the numerical data. In categorical data, there is no max value, no mean value. Why? Because every value have the same importance. For example, name. Let's take the name is the categorical data. Based on the name, we can't prioritize the people. Yes, he is the name X. So he is very high priority people. His name is Y. So we won't give any priority for the Y. We can't say like that one. So we can't apply this describe function on the categorical data. For example, let's say categorical data, let's take the gender. We know there are the 3 categories: male, female, transgender. But coming to the some education, shall we, that is also categorical data. We take
Yes. Yes.
B pharmacy, some MCA, MBA, all are degrees. We can't say any prioritize to the BTech to the people who are B pharmacy, the people who did some other course. So that is a category. But we don't know how many categories are existed in that feature. If we want to see unique IDs means, for example, it displays instead of that one, you can take other number of shares. How many shares does it have? You can see here if you people want. See, number of shares are these many. What is the length? How many categories does it have? 501. So out of the 7000, there are the 500 categories of the shares. Actually, we will apply our unique mostly on the categorical data. For some time, based on our requirement, we apply for the numerical data also. Why? Because nominal categorical data, or ordinal categorical data. Ordinal categorical data also categorical data, but how it represents in numerical. For example, ordinal means first rank, second rank, third rank, fourth rank. That is also rank also categorical data. Why? Because if in our class, if we have the 30 students, we will get the 30 ranks. So no rank will be repeat. So it is the categorical data. But the here for the each and every point we have the difference, some difference. For example, let's take the whether a education technician or some other admin, some other business, there might be no difference between the one category to another category. But whenever we comes under the ordinal categorical data, there might be some difference. We will give high priority for the first rank student instead of 10th rank or 12th rank. That is also categorical but the difference one point to another point is the meaningful. At that point, we will use this unique like this. If you people want to see how many different patterns exist in this feature, this unique function will be useful.
Okay.
Yes. So if you can check whatever the feature you want to check like this. Let's take this status published. It have the out of the 7,050, it have the 6,913 different. So sometimes sometimes we treated it as if it is really continuous data based on the nearest points we will get information, but it is not continuous data. If it is a categorical data, it there is no use to use this particular field, so we will get that type of different. For example, let's take the categorical. This is the exactly categorical data. It have the four different unique values, that is the video, photo, link and status. Only four. Actually, for the clustering, it's not useful, but these techniques we need to check before going to the some to build a model to understand the
Okay.
how particular feature is behaving.
Uh-huh.
Yeah, actually, these are all dummy data sets. That's why you people did not observe any importance of the features. But whenever we go for the real time project, there might be some features we can't eliminate those features, we can't include those features. By
Okay.
eliminating those features, accuracy will be decreases. By including that feature, accuracy might be decreases. But we need to understand which feature. For example, we can't build model by eliminating, by including each and every feature. What we'll do, we'll by seeing the data, describe function, info function, some head, we are able to identify some unwanted features. First, we will do that by using all features. We will get some accuracy. Then after, we will drop some unwanted features. If the accuracy is increases, that's fine. If accuracy decreases, what we need to do? We need to include some features out of the deleted features. That means the features what we deleted, for example, I have deleted 10 features. Out of the 10 features, there might be 3 features are very important. Due to that deletion of that 3 features, here my accuracy decreased. So how do we find? We can out of 10 features, we can't include each and every feature every time. Then after, by selecting 2 features. At that time, by doing this type of analysis, maybe we will get some more information. Info function, out of the 16, I have deleted 4. Those are the who are have the all null values. Column 1, column 2, column 3, column 4. We already. So here I have taken some classification problem. Actually, this is the data set not for the clustering. I have taken some classification data. Why? Because let's see here, I have clustered into the 4, 6, but we don't know how accurately this came in clusters. If we want to check that, if we want to check performance of the model, we need the some ground truth values. Then only we will compare our predictions with ground truth values. We will decide whether the model behaving as expected or not. That
Yes.
that's why I have taken here classification problem. That's why df, this is the status type, this is the dependent variable. That's why I'm assigning this variable to the y, that is the output variable, remaining variables to the x. Okay.
Yes, sir.
Yes. Let's take yeah, before going to the k-means, I already told you we need to do the why, because k-means mostly effective on the outliers. Why? Because if outliers present in the data, whenever we calculating the distance between the centroid to the outliers, our centroid will be goes from the near to the outliers. Why? Because based on the average distance of the all data points, we will decide the centroid. If there might be 4 or 5 outliers present, what will happen? So to comparing this cluster to those outliers, what we'll do, we'll change our cluster centroid. So to eliminating those problems, I am performing some previously I introduced in this Jupyter notebook, I introduced the standard scalar. There might be other one also. That is the mean max scalar to normalize the data. There might be one wrong point. Where is that? In which column? I did not find any date column here. Okay, status published. We need to drop this one. We already dropped this one. Sorry, something went wrong. I think I did not execute this cell. Yes, now we have the only this data. So I performed a normalization. Then after I assigned columns. Okay. Here again I'm using number of clusters to by randomly. See how many clusters I assigned. Initially I have taken 2 clusters. So it gives the cluster whether it is related to the class 1, class 2 like this center. So what we'll do, we need to check it with the y labels. Previously we have taken status type as the y, our ground truth value, our dependent variable. So now we need to check our cluster k-means labels with that y labels. For example, let's check. See, what is the result? Out of the 750 samples, 63 samples are correctly labeled. How many samples correctly labeled? 63. That means
63.
what is the accuracy score? 0.01. So we don't know the how many patterns are existed in this one. That's why I'm going for the elbow method. What will happen to this one?
We need to import something like spill or something.
It's working for the X only. Yeah. Actually, previously we have given 1. We can't cluster with 1. Why? Because 1 means all data points related to the same pattern. That's why I gave here 2. Okay. Let's take there may be a lot of distance from 3, 4, nearly 5. It comes where the reduction of the distance between the one cluster to another cluster is very less. Okay.
Okay.
Yeah. Let's check with
Ma'am,
from 2
the reason I didn't understand, we have given 1 and now we have given 2 there, right?
Yes.
So means where was the issue?
For example, K means clustering means we need to group data point into number of clusters.
Correct.
If we give one, that is the one group. There is no division, no identify of the patterns. There might be
Okay.
one cluster means we don't need to cluster anything.
Yeah.
If we want to group into two clusters, then we need to apply k-means.
Okay. Okay.
Yeah. If there might be one pattern, we don't need any to do any clustering, any grouping, anything.
Yeah.
All
Yes.
data points are related to the same group.
Yeah. So it is
If is there
minimum range.
any different patterns are 2, 3, 4, more than one patterns are exist on the data point, then only we will do cluster.
Okay. 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 So it is taken as a minimum range between 2 and 11. So it will
Yes.
not cover 11, but it will go.
So that's why I have changed it to 1 to 2. So
Okay.
let's check if we give, we already checked there is the 0.01%. Let's check with 3, 0.02%. Why? Because there is a lot of distance. Let's check with 4, 60% accuracy. If
Mhm.
you people want, let's check with 5 also. Again 0.01%. That means there might be 4 different patterns. That's what I said. If we have seen this one, we need to check 4, 5, 6. Then we will get the how. Actually, we don't know. This one also gives the some assumption. So instead of checking 2 to 10, it's better to check with 4, 5, 6. For example, if
Mhm.
there might be 10 or 20 different patterns are existed, it's not that easy to check with two cluster, three cluster, four cluster till 20. By using this elbow method, we can able to identify the what is the nearest cluster. So by, for example, here we have decided this is the 5. We need to check 4, 5, 6. If we are not able to get good accuracy, then you can check 3, 4, 5, 6, 7. So we will for the one some number, we will get the good accuracy like this. That means there might be 4 different samples, 4 different patterns are exist on the given data.
Okay. So means after that we will change the value of that number of clusters. Then the accuracy will go constant.
Yes.
Okay.
For example, let's take Akash. If we have that in our data, we have the 4 different patterns.
Mm-hmm.
Yeah. But whenever if we go for the 3 different or 2 clusters, what will happen? Some 2 groups comes under one cluster. Whenever we calculate the distance between those data points, that data points lies on the cluster to centroid, what will happen? Here we are combining 2 clusters into one cluster. So the distance will become very high. Let's
Okay.
take there might be 4 patterns only existed, but we have taken 6 or 7.
Mm-hmm.
What will come? The data points which are lies under one cluster, it will become 2 clusters. That means some points will go for the other cluster, some points will go for the other cluster. That might be also problem. So it is mandatory how many patterns are existed in the data. The identification of the number of patterns existed on the data is the mandatory for the k-means clustering. If we have select less number of clusters, if we have select high number of clusters, it will become a problem. For example, let's take this same 3 dimension. These are the 3 clusters are existed. But
Mm-hmm.
instead of taking 3 clusters, what we did, we have taken 2 clusters. What will happen? The red, which is the red, is near to blue and near to green. But the distance
Mm-hmm.
between blue to green are very high. What will it happen? The data points which are lies under red cluster, it will become separate here. And these data points comes under blue cluster. These data points comes under the green cluster.
Mm-hmm. Yeah.
But what we will do, we will assign one centroid for the each cluster. We will check what is the distance between this centroid to each point. What will happen if let's take this is the blue color, what will take here, this point or this point will take as the centroid. But
Okay.
if we want to combine this red cluster also, what we will do, the points which are lies here we take as a centroid. Then what will happen, the distance here, if we have taken this is the centroid, the distance between this centroid to these points are very less. But if we have taken this point as the centroid, what will happen? The distance between this point to these points also high, these points also very high.
Yeah.
This is the problem we will get instead of taking 3 clusters, if we have taken 2 clusters. Let's take this is the 3 cluster, we have taken 5 clusters. What we did? We have taken 5 clusters. Here, what will happen? So there are very less point in green. So what we do, we take the this is one cluster. But coming to the red and blue, what we will do, these are the very near points. We grouped this cluster into one group and these points into one group. Again, red also we will split here and we'll do this is one cluster, where this is another cluster. At that time, what will happen? The distance between this cluster centroid to the distance between this cluster centroid is very less.
Okay.
Why? Because here is one centroid, here is one centroid. Here is some points. These points, some points near to this cluster, some points near to this cluster. So if whenever new points exist here, it's very typical to identify whether that data point is related to this cluster, related to this cluster. Why? Because these data points all are comes under one cluster. But here we are trying to divide this one cluster into 2 clusters. So
Okay.
the distance between the one cluster to one cluster is very less. So
Yes.
we need to check what is the distance between each point is less or not. At the same time, the distance between the one cluster to another cluster is very high or not. That might be also one of the parameter. So that's what whenever I uh, in my last session I explained about that. There are the one is the inter or infra. In one parameter, we will check what is the distance between the each and every data point in the cluster. Another parameter will calculate the what is the distance between the one cluster to another cluster. The distance between the one cluster to another cluster, always we need to check whether it is high or not. At the same time, the distance in the same cluster, the distance between the each data point lies on the with less distance.
Okay.
Yeah. So like this, we'll do the class. We will measure the performance also. Let's check a hierarchical is executed or not here. Yes, executed. See, in this dendrogram, how do we define how to decide how many clusters are existed in this pattern? Let's take based on this distance. Here, this distance is the distance between the one cluster to another cluster. Did you understand? Here, this one, here to here, the distance between the one data point to another data point in vertical. Here, this vertical lines means the distance between the one data point. But here, the horizontal line, this is the distance between this cluster to this cluster.
Okay.
Let's take this blue diagram, blue line. Here the distance between this cluster, orange cluster and the green cluster, that distance is very high.
Okay.
Coming to the whenever we want to decide into 4 clusters, this is this orange one or this green one. Here the distance between, let's take this green one, the distance between this cluster to the distance between this cluster is defined through this line. So based on this line, we will decide. Uh, let's say, let's check. We won't take mostly 2 clusters. Let's take instead of checking every time 2, 3, 4, 5. It's easy to check 2, 4. Then after, if you people want, if you feels the distance between this cluster to this cluster very high, you can check with 6 clusters by cutting like this. Okay. That's what if you people want to decide based on this distance. But it is old method. Most of the people won't prefer this hierarchical. Actually,
Okay.
K-means also algorithm, which also uh, actually based on the hierarchical only. The concept behind K-means is the hierarchical. But you people know, every time the people work and they will implement algorithms based on the performance, based on the accuracy. For example, it gives the one model we have the it gives the good accuracy, but it take lot of time to execute to perform the operations. What is it useful? For example,
No.
let's take the stock market. We need to uh, take decision within fraction of seconds and milliseconds. Why?
Yeah.
Because within fraction of seconds, our fate will
Change.
change in stock market. So,
Yes.
if for example we build one model, AI model, it will predict the whether the particular stock market goes up and down, but it takes 2 hours, 3 hours. What will happen within these 2 hours? That stock will go rise, go up again, go rise again, go less, will drop. There might be chance. So the based on the performance, most of the people will prefer K-means.
Okay.
That's it. Here I want to check with the first four clusters. That's why I gave the four like this. You people go through these notebooks. If you have any doubts, please ping me. We'll clarify whatever doubts you have. We'll clarify.
Okay. Yeah.
Do you have any doubts regarding now regarding this concept?
No, ma'am.
Yeah. No, ma'am. It's fine.